Hello, everybody. I wanted to share this beginner-friendly technique for creating this pulsing animation along lines. It is fairly straightforward, but I think very effective in a lot of situations. So let's get into it. Okay, let's go ahead and jump into Houdini now. I'm going to go ahead and lay down a geometry node and name that pulse. So inside of that, I jumped in just by clicking enter. We can drop down a line, and then right after the line, we will drop a resample node. And on the resample node, we can control the number of points we have on this line. So if I go ahead and press this to enable my point count, I can go ahead and either lower the length or increase the maximum segments just to have a more highly divided line. And more importantly, I can click this checkbox to export a curve view attribute. So what a curve view attribute does, if we click on the eye here and alt click on the curve view, it generates a 0 to 1 attribute along the length of the curve. And if you click on your geometry spreadsheet at the top here, you can see the curve view increasing across the entirety of the line. So what we can do is essentially offset this curve view to create a pulsing type animation. So in order to do that, we're going to go ahead and use VOPs, which is essentially a visual way of doing vex code in Houdini. All right, so I'm going to click this to disable the visualizer and go ahead and lay down a point VOP and connect that up, and we can call this pulse animation. All right, so if you dive inside the pulse animation, the first thing we want to do is actually bring in our curve view attribute. So I'm going to go ahead and lay down a bind node, and I'm going to stretch out this window to give us a little more space. And so on the bind node, we can rename the parameter we want to bring in, which is curve U. And now if you connect your curve U up to CD, your color, we can see this black to white gradient that the curve U is giving us. So that's nice. So now we want to actually offset this attribute. So what we can do is lay down an add and add our time to our curve view. And so what that is going to do is just actually immediately increase our line to white, because now it's basically increasing the value. So at 24 frames it's 1, 2, 3, and if we look at our geometry spreadsheet, we can see our color value is just steadily rising. So we actually want to make this loop back on itself, and an easy way to change a continuously increasing value into a looping type animation is using a modulo operation, which is essentially giving you the remainder of the division. So immediately you can see if I press real-time toggle that now we actually have a moving gradient along our line. All right, so one thing we may want to do with that is adjust the direction and the speed of this. So I'm going to go ahead and lay down a parameter node and call this speed molt, and then the label is kind of the nice looking name that will be displayed, so I'll name that speed molt with a correct capitalization, and then I'll multiply that across the time. And so to see this speed multiplier we've just made, we can go back up a level, and if we look at our pulse animation here, we'll see we now have this controller on our point VOP. And so if I go ahead and play this, if I go lower, the animation will be slower, and then if I go negative, it'll reverse direction. Now for user experience, we can simply click on this gear in the top right corner and go to Edit Parameter Interface and click on this speed mult parameter we just made and reset the range to something like maybe -5 to 5. And go ahead and apply that. And so now our bar, we can just slide between those values. So I'll go ahead and leave this at -1 for now, and we can confirm that we are now moving this animation upward. And so if we dive back into the pulse animation, ideally we'd want more control over this gradient. Right now it's just 0 to 1 across the whole line. What if we want to make it just like a small point or a small region of the line that's flowing along itself? So the way we can do that is actually with a ramp. So if we go ahead and put down a ramp parameter after the modulo, we can go ahead and make this a spline ramp and call this something like pulse length. And this is totally arbitrary, whatever descriptor you feel like fits most. And then if we go back up a level, we can now see our pulse length ramp here. And so now what we can do is actually kind of start remapping these values. So if I turn it all to black, we don't see anything. But then if I start adding a point, we can kind of isolate a region of this line to be pulsing. And so now we have this small pulse going up the line. And what we can do to kind of tailor this to our own look is adjust this ramp. So if you wanted to have like a sharp pulse with a long gradient tail, you could make that in your ramp. And so that's pretty cool. You could even add another little point up here and have this kind of dotted pulse or double pulse. And so that gives you a lot of flexibility with kind of creating the effect that you desire. And so one thing that we might want to do too is that you can see that this is always a continuous cycle. So it's going 0 to 1, 0 to 1, and looping back to the beginning of the line. So it's going between the points and back to the beginning. It would be nice to have a delay, so maybe it sends out a short pulse and then waits and then a short pulse. So in order to do that, we can actually use our modulo operation. So let's make another parameter here and call it delay and hook it up to the modulo. Okay, so what this will allow us to do is change essentially the length of the cycle of the animation. So the modulo has been set at 1, so it's going from 0 to 1. If we set it at 2, then our animation will be going from 0 to 2, but since we have this ramp, we're clamping everything above a value of 1, and that's going to look black. So it, in essence, is simulating this type of delay. So the larger this number is, the longer it'll be between the pulses. Now we're getting only a pulse every 10 seconds, essentially. If you go lower, like 0.1, you'll actually start creating this kind of dotted line effect. But I will go ahead and maybe put like 1.5, so we'll just get 1 pulse with a slight delay, maybe 2. All right, and so I could go ahead and change the speed now. Now I get 1 fast pulse with a slight delay. And if we go back into our VOP, our ramp is essentially clamping this value, but for good measure, I like to usually put a clamp here because when we raise this modulo operation above a 1, the values are technically going over 1. So for good measure, I like to add this clamp just to make sure none of our values are actually going over 1. And so that is essentially the pulsing setup. One thing we might want to do to expand on this setup is now do it with multiple lines. So let's test that out. So I'm going to lay down an add node and go ahead and just create a single point, add a point replicate to create many points off of that. And in the noise in the shape parameter, I'll go ahead and change the UI size to 0, so we just have points on the ground. I'll go ahead and change this to a circle on the ZX plane. And now what I can do is copy to points, a line. So now we have many lines, and I'll go ahead and just copy and paste that resample node that we made before. So we have many lines with a curve view attribute. And now let's go ahead and copy this node over to here and see how that looks. So our pulse animation is working, but you can see it's all uniform. So that's not really that interesting. Maybe we want to vary these animations between each line. So let's expand our setup just a little bit. We need some sort of way of differentiating these lines. So what I'm going to do is add a connectivity attribute. So it'll create this class, geometry spreadsheet, class attribute for each one of your lines. And so that'll let us vary the animation across our lines. All right, so I'm going to jump back into the pulse animation, and I'll go ahead and use a bind node to bring in that class attribute we just made, and that is an integer. So we'll change the type to integer. And what we can use this to do is simply offset our time. So I'm going to go ahead and create a random offset by laying down a random node and connecting this class to the random node. So I will go ahead and add that right after our multiply. And let's see what we have here. So now we have all the lines shooting randomly, but we might want some more control over this. So by default, our random VOP here will export a value from 0 to 1. What we can do is lay down a multiply node and make another parameter and maybe name this random intensity. And this will control the amount of offset we have on these lines. So let's go up a level, and this is starting to get a little messy, so let's go to our edit parameter interface. I'll go ahead and kind of reorganize this. I'll drag the pulse there. Maybe we can drag a separator from this left menu here just to make it look nicer. We can also put a folder down. This is all just for aesthetics, and drop everything in there. Change the folder type to simple and name this controls. All right, so when I hit apply, you'll see that just is an aesthetic tweak for these controls. All right, so now we have this random intensity. I'll go ahead and play. You can see at 0, we're back to a uniform animation, and as I ramp this up, these lines will start having more of a random offset. And so you can dial that in to get a much more sporadic random animation, or if you want more of a uniform pulse, you can go ahead and set that to 0. So let's try maybe a value of 0.5 for now. So we have a small offset between each line. Okay, so that is essentially our setup. So pretty simple, pretty straightforward, but I think it's an effective way of creating this type of motion graphic-y pulsing. And so now let's go ahead and recreate something more similar to the artwork at the beginning of this video. So one thing I might want to do is, if I jump into our VOP again, I'm going to actually export this attribute to something called loom. So far we've just been using CD for visualization, and it's not necessarily the best practice to do that, so we'll go ahead and bind it to attribute of our creation, and then we'll be able to use it more easily down the line in shading and in other instances. So what we can do to make this look a little bit more like the artwork at the beginning, let's go ahead and make these lines a little longer. I'm gonna increase the resolution of them a little bit as well, and we can go ahead and add a sweep node to actually create some geometry. We'll do round tube, lower the radius a bit, and we can export out end caps. So we get a closed tube, and let's add a little bit of noise. So you could do anything you want with these lines. It could be a vellum hair animation, it could be anything, and the setup will still work as long as this has a curve view attribute and a class attribute. For this, let's just create a more interesting shape using noise. So before our pulse animation node here, I'll add another point VOP, and I'm going to use this to create just more of an interesting shape with these lines. So let's dive inside here and create an anti-aliased noise, and I will go ahead and add that to the position of the points. And we'll make this noise a 3D noise, so it's offsetting these points in every direction, and we'll then pipe this into P. And you can see now we get a noised up bunch of lines. To make this a little bit more interesting, we can play with the frequency and the amplitude, and one thing we might want to do is vary this along the length of the curve. So we can go ahead and bring in our curve view attribute again and multiply it against this anti-alias noise, and now we're essentially pinning our lower values and letting the noise affect the top of the curve more. And you could pipe that into a ramp or a fit to adjust when that noise starts affecting the line. And so let's go ahead and just play around with these settings a little bit. All right, so this is you know, something a little bit more like the artwork at the beginning. For that one, I did use just a quick vellum sim that I had done previously. You can even, if you wanted to, do something like animate this noise. We could go ahead and add time to the offset, for instance, and you could get a weird flowing animation that you would need to kind of dial that in more. But for now, just to demo this, I'll just go ahead and leave this a static shape. And so if we go back to our pulse level here, let's go ahead and preview this loom by alt-clicking on it and make sure we re-enable our visualizer button there. And so now we can get a visual representation of what we have. So that's pretty cool. And so now really the sky's the limit. So we can go ahead and maybe subdivide this just to get some even smoother curves. And so one thing that I did do in the preview animation is displace the luminance areas of this. So to do something like that, for example, you could drop down another point VOP, add a displace along normal, type in the P, bind in that luminance attribute that we had created, and pipe that into the amount, and then pipe this back into P, and then we can reduce the scale. And then you can have this kind of bulged out pulse. And really the sky's the limit then. Once you have this luminance attribute, or loom as we named it, you can really do anything with that. You could apply this to any setup that is made out of lines with a curve view attribute. So thank you all for watching that. If you have any questions, please leave them in the comments. If you like this type of tutorial, please let me know. If you're interested in how I brought these lines into Solaris and rendered them with Karma and set up materials, let me know and I can make a follow-up tutorial. And I hope everyone has a great day. Thanks. Bye-bye.